Hey all, I hope you are doing well. In this video, we're going to explore MCP, Model Context Protocol. We're going to try to understand how it works and really look under the hood. So, what is MCP? LLMs, by their very nature, are token only or text only. So you ask a question and you get an answer in form of tokens, of text, of a response. So they can only output tokens. What if LLMs were capable of performing actions? Instead of just giving me an answer to my question, they could actually do something and solve my problem. And this ability to run actions, to execute actions, came with this very interesting paper called React, Reasoning and Acting. And the key insight behind this paper is that if you provide a list of potential actions to an LLM and ask it to output which action might be useful to solve a certain prompt, so for instance, if it needs to grab some information that it doesn't know, it just calls the action search with that information, with an input, and gets the result. And so giving the LLM a list of potential actions and asking it to output the name of the action with its input, and then having the runtime, the environment actually run that action and provide the result as an observation to the LLM. So the LLM, by simply outputting the name of an action, somehow gets the result of that action, the observation from the real world. And that is done by the host program, by the application that's calling the LLM. And there's a very cool example of that. So we have this system prompt that just tells the LLM that here is the list of your available actions. So for instance, calculate, and that's how you call it, or look up on Wikipedia with an input, and that's how you do that. And you explain that if you have a question, you should think about which tool makes the most sense to answer that question, and then you call the tool or you call that action with the appropriate input. And within the program that's hosting the LLM, that's running the LLM, you watch for patterns that actually call an action. And so we watch for this pattern that calls an action with some input. And since we have predefined actions, which are actually functions in our program, when we see that action in the LLM output, we actually call the function and provide the result as the result to the LLM context. And we can see another example here. For instance, there is the action input, and we run the action, and the result of the function of the tool is added to the LLM context as an observation. And by doing this, by asking the LLM to simply output the name of the tool or the action that it thinks might be helpful to solve a problem, and then actually running that tool or action in the environment and providing the result, we give LLMs the ability to act, to become agents, to become agentic. And this seemingly simple idea is very powerful when you apply it. And it brought a lot of interesting applications, but a fair amount of hype. So giving LLMs the ability to call tools is pretty powerful. As we saw in our example, the integration with the tools was specified in the prompt. So there was a certain format, how it should be called, and how the arguments or inputs to the action should be passed. And that was very specific to that system prompt. Another AI application could have its own format. And so its tool integration would be completely different, and the tool would not be compatible. And same goes for the tools themselves. If I have a server or service exposing some functionality, how to make use of functionality, how to become aware of it is dependent on how that server or service exposes these tools. What if we had a format, a standard that we could all follow on how to call tools, how to expose tools, how to list the available tools, how to notify changes, how to communicate errors, and we could all follow this standard. And if I have an application that follows it and you have a server that does that too, we could just work seamlessly together without having to change integrations each time. Well, this standard is basically MCP. It's an agreed upon format that AI applications and servers follow to enable interoperability. And I like to think about it. I like to think that it's a lot like HTML and HTTP. It's just a way for different clients, the browsers, to communicate with servers, web servers that offer a certain service, and the agreed upon format is the same, but the underlying implementations are different. So you can have different browsers, or you can have different LLMs, different AI applications, and you have different servers, different tools that offer functionality. But as long as we all use the same format, use the same standard, well, it works. And having a standard unlocks a great deal of usefulness. So what basically happens is any function that can be run by a computer, any REST API, any API really, can be consumed and used by an LLM as long as it has this layer of MCP that describes what it does and how it can be called. And the LLM, having access to that, can make use of it whenever it deems it useful or necessary. And this is really incredible when you think about it. A standard, however simple it might be, unlocks a lot of potential. So within MCP, we have multiple projects. We have the MCP specification, which outlines the requirements that implementations of the protocol of the standard should follow, because MCP is just a standard. You have multiple different implementations of it, and the specification is the framework, the guiding principles, and the message formats, and the exact schemas that each implementation must follow to be fully interoperable with other implementations. We have the SDKs, software development kits, which are libraries that for different programming languages that people can use to implement MCP. Then we have development tools that help with the development of MCP, and we have reference implementations of servers. Okay, so let's talk about the MCP architecture and its concepts. There are three key participants in MCP. We have the MCP host in yellow, the MCP clients within the host, and the MCP servers. So the MCP host is the actual AI application. So this could be Claude Desktop, this could be VS Code, this could be Cursor, any AI applications that want to make use of MCP. An MCP host, when it wants to make use of MCP functionality by MCP servers, will instantiate MCP client. So one MCP host instantiates an MCP client that speaks the MCP protocol to communicate with an MCP server to grab its functionality and make use of that functionality. And for each MCP server, we have an MCP client. So in our example here, we could imagine the MCP host being Claude Desktop, and it wants to make use of the file system functionality. So there is an MCP server that offers some capabilities to interact with the file system, to list files, to check out their content, delete files maybe. And so to do that, it instantiates an MCP client that will have a one-to-one connection with that MCP server. And whenever the MCP application, the Claude Desktop, wants to interact with the file system, it will send the request through the MCP client. And if it wants to interact with different MCP server, for instance, the database, it will ask the MCP client interfacing with the database to do that. And the MCP servers are just computer programs offering some functionality. So any program that has a function that can be useful to an LLM can be considered an MCP server. And that MCP server will expose this functionality through either standard I/O. So if the MCP server is in the same machine, we don't need to go through the network, through the internet. We just use standard input and output to communicate between the MCP client and the MCP server. If this is a remote server residing on a different machine on some remote location, we use HTTP to communicate between the client and the server. So two types of servers, standard I/O servers and HTTP servers. So there are two layers in MCP. There is the data layer, the inner layer, and this defines the actual message that are exchanged between the client and the server, such as the list tool data message, or the executed run a tool message, or give me the list of resources, or let's start a session. These are the actual messages that are exchanged within the MCP protocol. Then you have the transport, and that's how the messages are actually being transmitted from the client to the server and from the server to the client. So, data layer. In a computer program, we have functions, we have methods. So this function can make use of that other functionality within the same computer program, within the same process. But it's possible to make use of different functions stored in different processes. So you can have a client process that wants to run some functionality and it does not have access to it, but it knows that it exists on some remote process, and there are ways to call this procedure remotely, or as we call it, RPC, remote procedure call. So there are multiple ways of doing RPC. So one of the coolest ones right now is probably gRPC, which is the Google way of doing RPC. It's based on protobufs and on HTTP2. But there are other ones. So you have a way of doing RPC in Java that is called RMI, which stands for Remote Method Invocation. And you also have a bunch of others. The one that is used by MCP is called JSON RPC, which is JSON Remote Procedure Call. And it looks something like this. So if a client process wants to run a method on a server and get a result, it sends a payload very much similar to this one, which has a method name and the parameters that needs to be passed to this method. So suppose our client process does not know how to subtract, and it knows that some server exists and has this subtraction functionality. So it sends this method, which is the subtract method with these parameters. The server receives that method, executes it, runs it, and provides a response containing the result. And we notice that both requests have an ID, so they are mapped together. This also allows sending multiple requests and sending a response out of order, but each request will be mapped to its response based on the ID. In JSON RPC, there is another kind of request that does not have an ID, meaning it does not expect a response, and it's a notification. It's basically just, hey, FYI, this is what's going. And this is usually an update. And in the case of MCP, it's mostly informing the other party that something changed. So for instance, the server tells the client that the list of tools has been updated. So JSON RPC, this remote procedure call protocol is used to package data and send it from the client to the server and from the server to the client. This is used to initiate the session. So the client initializes a session. Then it's used to negotiate the capability. So the client tells the server, this is what I can do, and the server answers, this is what I can do. And based on that, this will inform the subsequent requests. And as long as the session lasts, all exchanges will be packaged in this format, in this JSON RPC format. So that was the data layer, the actual messages that need to be exchanged between the server and the client. But how are these messages transported? How does the communication actually happen? Because you can have some message and you can send it in different ways. You can send it via text message, you can call, you can whatever. This is very much similar to that. So the transport in the case of MCP depends on the server location. So if the MCP server resides within the same machine, we'll use standard I/O. If it resides on a remote machine, we'll use HTTP, or as they call it, streamable HTTP. And one can imagine that in the future, other transports may emerge. So you could use some message queue, or Redis, or a database, or what have you, as long as it is an effective way to send the actual JSON RPC payload, and both the client and the server understand it, it will work. So processes in the same machine can communicate via standard I/O. What does that actually mean? So let's take a look. So I have a terminal here. If, for instance, I do echo MCP is cool, and I redirect it to a file called test1.txt. So I am running a process echo that prints this string, and it redirects it to the text file test1.txt. So the standard output of this command, of this process, is writing to this file. So we are writing from the standard output, we are redirecting the standard output to a file. If I do cat and this on the other side, what I am basically doing is I'm running the process cat and passing the file's content to its standard input. And it indeed works. There's also a way to redirect the standard output of a process to the standard input of another one. So we are sending the output of the process to the input of another one. For instance, let's do this, and we grep. So we pipe the output of this with the grep command. So we have the output of the echo command as the standard input of the grep command. And if we look for is, we see that indeed grep has had MCP is called as its standard input, and it looked for the word is, and it found it, and then it printed to the standard output test. So as we can see, these commands, which are processes, are communicating between each other using their standard input and standard output. And this is exactly how MCP does it. So when we are running a standard I/O MCP server, what happens behind the scenes is that the MCP client will spawn an MCP server process, and it will have access to its standard input and standard output. And so whenever it needs to send a request, the MCP client will send the JSON RPC request to the MCP server process standard input. And whenever the MCP server process provides a response, it will send it via its standard output, which is read by the MCP client. So we have the MCP client, it sends requests to the MCP server process via its standard input, and it reads the standard output of the MCP server process. It's really simple when you think about it. So what I have here is the actual standard I/O client implementation in the official Python SDK. And what we can see is that the client is creating a process using the server configuration. And this is basically the path and the options specified in the server MCP server config. And then the way they communicate is we have the process, the MCP server process standard output, which is sent to the client read stream, client input. And whenever the client wants to, so whenever the client wants to send data to the server, so the client process wants to send data to the server process, as we can see here, it sends the JSON RPC to the server process standard input. And any SDK, whether it's in Golang, in Java, in JavaScript, for the standard I/O implementation of MCP, all it does is this. So you have the server process that communicates with the client process through standard input and output. So this happens when both processes are on the same machine, which is convenient. We don't have to go through the unsafe internet. But if the server process, and I think this is the more often than not, the server process is in some remote location because we don't want to host all our MCP servers. We want to make use of what's available out there. So one convenient way to do that is to go through HTTP. So the other transport MCP makes use of is HTTP. HTTP is an internet protocol. It is built on top of TCP, and the way it usually works is that you have a client that sends an HTTP request to a server. The HTTP request can have a verb in it, such as get, to get a resource, post, to create a resource or create something, put, to update, delete, to delete, and so forth and so on. The server, based on the request, sends a response, either some document or some information or some JSON. And that's the most common use of HTTP. But we have some other ways of communicating via HTTP, one of which is the server sent event. So instead of the request response way of doing things, the server can just send messages to the client without specifically answering a particular request. And those are called server sent events. And this is usually done when a client wants to subscribe to a server for updates. So it gets updates events from the server to inform it of some change in the world. And we can take a look at that. So that's a pretty straightforward example. We have a JavaScript HTTP client that subscribes to an SSE demo endpoint, and then it continuously receives events, which are messages, which is data from the server, and performs this action whenever a new message is received. The same thing happens for the MCP client. It subscribes to this SSE server endpoint, and then the server can continuously send messages to inform it of things. And the most common one is that an update has happened, that the list of tools evolved, that it got some status update on the MCP session. And behind the scenes, it looks like this. This is just the body of the HTTP response. It has a data bit and that data. And the header is event stream, I believe. And that's it. Instead of having the whole response in one TCP request, it's continuously sent through multiple ones. And so initially, in the earlier version of MCP in November 2024, the way the HTTP transport worked is you had the client send a GET request to a server on an endpoint, and then the server would send a response that had another endpoint in it, and the client would use that second endpoint to send post requests of its various calls. So it can list the tools, call the tools from that second endpoint, and the first endpoint was used by the server for its SSE, for its server sent events. But I guess that brought some challenges, and a newer version of MCP, the March 2025 one, consolidated these two endpoints into a single one that supports both GET and POST HTTP requests, but also SSE events and streams and chunks. And it basically gives the server more flexibility in implementing its HTTP communication with the client. And in addition to that, since the server is remote and we are accessing resources that belong to us remotely, security is very important. And that's why the MCP protocol, the MCP standard, puts a lot of emphasis on security, and it gives recommendation on the various authentication schemes that can be used. So you can use bearer tokens, OAuth, API keys, and at the heart of it, these are some schemes that allow the client to authenticate itself to the server, and that is done through some secret information that is sent through the HTTP headers. And we can take a quick look at the Python SDK HTTP client. In particular, its handle post request method, which, as we can see, sends post request to the server URL. And then depending on the content type of the response, so if it's JSON, it handles the JSON response. If it's SSE, it handles the SSE response. And as we said, in all these, the actual body of the data is in JSON RPC format. And the JSON response has just a content type of application JSON. And SSE, as we said, it's text event stream. And that's pretty much it. So transport is just the way the client and server use to send the JSON RPC payloads and exchange them. And in the future, we can imagine new transports emerging. So we talked about tools that the server can offer clients, but there are other primitives that the server makes available to the client, and we'll take a look at those. But the client can also offer some functionality to the server, and this is what I found most intriguing when I was digging through the specification, and we'll explore that in a second too. So let's start by the tools, the actions. So the actions, as we already said, are functions that the server can run on behalf of the client and provide a response. The client can call the RPC method tools list when it starts a session with an MCP server to get a list of all its available tools, to discover those tools. And then during the conversation with the LLM, when the MCP host application deems it useful to run a certain tool, it emits a tools call RPC request. The server runs that function, that tool, and provides the response. And a tool definition looks like this, something like this. So we have the name of the tool, its description, and the properties or arguments needed to execute that tool. So for instance, we have a search flights tool, and what it does, it looks for available flights, and we need the origin, the destination, and the date. And bear in mind that from the LLM point of view, this is all it sees from that tool. And this tool definition is loaded during startup when the MCP server is connected, and the user doesn't have to do anything. So the LLM gets the tool definition, and whenever at some point in the conversation we talk about flights, the LLM sees that it has access to this tool, and if the user asks for a certain flight, it can send this request to that MCP server and get a useful, helpful response to the user, which is pretty cool. This plug and play capability. And so we can see that we can have different kinds of tools. So there's a create calendar events and the email event. They are walking us through the process of planning a trip using an AI assistant, which is pretty cool. So one other primitive MCP servers offer to clients is resources, which is basically context data, and it's any kind of data exposed from files, APIs, databases, what have you, that can be useful and relevant to the task at hand that once added to the context makes for a better result. So This could be user preferences. This could be information about a relevant item. So in the case of planning a trip, it could be information about the destination city and the activities it has to offer. And resources can be dynamic. So you have a template and then you fill it with your particular resource. So in this case, based on city and category. And the specification doesn't mandate any implementation or constraint. So the MCP server can be as flexible and as it needs and implement the resources the best way it sees fit. So the protocol operations are resources list to list the resources or to list the templatized resources and read the resource, a certain resource. And you can also subscribe to resources so you are notified when there is a change or an update. And in the example of planning a trip, we could get the different events for that year. We can ask for the user's travel documents, so we can make the various reservations, and also the history, so we know what they like and tailor the experience based on that. And that's pretty cool. And this is what the request payload looks like. Finally, the last primitive MCP servers offer is prompts. And what prompts are, as their name indicates, is a chat prompt to describe a certain workflow to the LLM. And so the example they give is, in the case of planning a trip, is a detailed prompt on how to go about that. So it could be start by searching for a flight, then compare the flight prices based on the user preference, then look for hotels, book the best hotel, do this, do that, confirm with the user. So the way I like to think about it is it's adding some sort of prepackaged human best practices and intelligence to the LLM so it doesn't wander away and does something completely unpredictable. So it's basically packaged best practices for a certain task. And all these resources can fit together, so we can have a prompt to plan the vacation, and it has its own variables. So in our case, it's the destination, the duration, the budget, and the interests. And based on that, we request the necessary resources based on the city and on the interests. And then we make use of tools to look for flights, book hotels, and all that. So all these server primitives are used by the AI application, by the MCP clients, to enhance the user experience. Yeah, and that's it. So as I said, there are client concepts, and those are primitives offered by the client to the server. And to be honest, when I first learned about them, I thought they were a little bit out there, but you can argue that they have their uses. So the first one is sampling. And what sampling is basically is a way for the MCP server to request LLM access from the client. It's basically telling it, here is a prompt, here is an LLM, a chat query. Can you please forward it to an LLM and give me the result? And what this does is it relieves the server from the need of having access to an LLM. So as an MCP server, I do not need to have access to LLMs and pay for that API access. I could just delegate that to the client, which already necessarily has access to an LLM. And the way it works is the server sends a sampling create message request. And as I said, MCP always emphasizes the human in the loop aspect of things. So the client asks for the user's approval. If the user approves, the client sends the request to an LLM. The LLM sends the response. The user still needs to approve that response. And finally, once it's approved, the response is forwarded to the server. One other client primitive is routes. So what routes are, they are basically a way for the client to inform the server of the boundaries it should operate in. So if the server has access to a file system, it could say you should only access files within these directories. If it has access to multiple namespaces, it can constrain the namespaces the server has access to, or databases, or any time there is different scopes, different namespaces. Routes are an excellent way for the client to communicate that to the server. And the example I gave is basically the client tells the server which directory it should use to do its work. And this is a good tool that is made available by MCP to control the scope and blast radius basically for the different participants. Although to be honest, I'm kind of having a bit of difficulty seeing its practicality, but it's a good tool to have. And the last primitive the client offers the server is elicitation. This is a pretty cool one. What this basically is, it's a way for the server to ask for user input. So you have some MCP server that's doing some operations, calling some tools, doing some stuff, and it needs to know that the client is okay with something, or it needs to get some specific information from the client. So that's basically the server prompting the client to ask the user for some information. And one great example is confirmation. So when the server is done with some complex operation, it could elicit a confirmation from the user. And this is what exactly we can see here. So we can confirm the booking and then indicate the seat preference, the room type, the travel insurance, whether we have travel insurance or not. So the user is presented with a UI to specify these inputs, and that is sent back to the server. So it performs exactly the action that the user wants, which is pretty cool. So to sum up, on the server side, we have tools. That's, I think, the main value add of MCP, and that's the most famous primitive. So tools are actions carried out by servers. We have resources, and this is basically information and data made available by the server to the client to enrich, to enhance the LLM context with relevant data. And we have, what is it? And you have prompts, which are basically detailed prompts of how to perform a certain action. Think of the planned trip example. So there are multiple complex actions, and this provides a nice framework and a nice way to communicate best practices to the LLM. On the client side, we have the sampling, which allows the server to ask the client to perform some LLM queries, basically chat completions. We have routes to constrain the workspace of the server and set boundaries on which scopes it should operate. And finally, we have elicitations, which is basically asking for the user's input. And those are the MCP primitives. Now, okay, it's time to look at the detailed example. An exchange between an MCP client and MCP server. So all MCP exchanges start with the client sending an initialize request to the server, letting it know about its capabilities. So in this case, a client is capable of elicitations, allowing the server to ask for user input. It sends the client info, so which version of the client are we running and what's the name of the client, and also the protocol version. The server answers with pretty much the same thing, its own capabilities. So the server supports tools, but it also has a list change, so it can notify of any changes to the list of tools. It also supports resources, and it provides server info to the client. Notice that both the request and the response have this protocol version field, This basically allows both the client and the server to ensure that they are compatible with the other participants' protocol version. If that's not the case, the session is just aborted. And this is a great way to ensure future compatibility. So once the client has successfully initialized, it sends this payload to the server, and we notice that there is no ID. So this is notification, letting the server know that it has been initialized, which is basically polite. FYI, I'm all good. So once the server is initialized, it will send a list tools request, a tools list request. And this basically asks the server for its list of available tools, and the server responds with a list of tools definitions. So we can see it has a calculator tool, and it has a description of what it does, the arguments, and a weather tool. And as we said, this is all the client, the underlying MCP host needs to know to make use of these tools. So just by having access to these definitions and the description of what the tools do, whenever the conversation with the user progresses to a point where the user, for instance, need access to some weather information, it knows, the LLM knows that it has access to this tool, and it can make use of it by sending this JSON RPC request to the server. And at some point in the conversation, the user is going to ask for the weather, and the server runs that function locally on the server hardware. It gets the response, and it sends it back to the client. The client forwards that to the MCP application, and the result is added to the LLM context and shared with the user. Let's notice that the MCP response has an array of objects, and each object has a type field. So in this case, it's text, but we can have multiple responses. So we can have some images, we can have some audio, we could have some future data type that has not yet been invented. So it's very flexible. Okay, let's take a look at a live example. So I have connected my Claude desktop to the Apple Notes local MCP server. So that's a standard IO MCP server. And I'm going to ask it to read the contents of my latest note. So the MCP host applications, which is Claude desktop, is going to instantiate an MCP client that's going to communicate with the Apple Notes MCP server. And it's running the list notes tool with the argument limit 1. This is basically to get only the latest one. And once it gets the name of the note, it's going to try to read its content and provide the note's name as an argument. And it will do that. And the MCP server is going to actually do the reading and provide the content as a response to the MCP client controlled by Claude desktop. And that response is added to the LLM context and displayed to me, the user. And that's really neat. So that's the actual power of MCP. So the LLM only knows about the tool definitions that the MCP server provided, and it can make use of those whenever it's useful to the user. That's what I asked for my note. So it called the tool. The server ran the tool and provided the results. And based on these results, the LLM answered my query, which is pretty cool. So my Claude desktop is the MCP host, and I have access to its logs. So there's this file called MCP log. And if we look at the log entries, the requests are exactly the same ones we just looked at in the documentation. So the client starts by sending an initialize request with client info. So in this case, it's Claude AI, and that's the version, indicating also the protocol version. The server responds with the same thing, indicating its capabilities. So the client had no capabilities, so no elicitations, no sampling, no routes. The server has a tools capability. So once the client is initialized, it's going to be polite and inform the server that the initialization is done by sending this notification. Then it sends a tools list request to the server, and the server proceeds to send the list of tool definitions. So the conversation progresses. At some point, I'm going to ask the server to fetch me the content of my latest node. So it calls the tool list nodes with the argument limit 1 to get only the latest one. And once it gets the name, it fetches the node's content, which is pretty amazing when you think about it. Like with these simple JSON RPC requests, we are giving the LLM the ability to call actual tools, and these tools could be anything as long as they adhere to this MCP specification. Anyway, I hope this has been informative. Thank you very much for watching, and have a good one. Bye-bye.